Good afternoon, everyone. Thank you for attending today's two-episode webinar on functional safety for automotive. My name is Laura Shaw, and I would like to quickly introduce our three hosts today who will be taking you through this webinar.
My name is Andreas Platzköster. I'm called Global Product Manager at the Academy for TUV. And I have been working in the automotive industry for several years, always in functional safety topics. And since 2007, I'm working as a senior safety expert for TUV. I've done a lot of assessments and so on. Yeah.
Thank you. And next we have Philip.
Yes. Good day to you all. My name is Philip Sturtwalt. I just finished retiring from, say, 43 years of experience between aviation, automotive, and semiconductors. And I've been an instructor for functional safety and Sotif since 2017 for functional safety and Sotif for the last couple of years.
Thank you. And lastly, we have Ruben.
Yeah, hi, my name is Ruben Strenske. I'm a senior functional safety engineer at TÜV Süd, work mostly on autonomous driving topics. And I have a background in robotics engineering, systems engineering for around 10 years. And looking forward to our discussions.
Thank you. So just to give you a brief overview on why functional safety for automotive is important, functional safety is crucial, particularly for its use of software, tools, and systems becomes more prevalent. In recent years, developments have taken place. For instance, introduction of ISO 26262 has provided a framework for managing functional safety throughout the entire development process. Additionally, simulation and modeling tools have become more prevalent, enabling engineers to test and verify safety vehicles, systems in a virtual environment. At TÜV Süd, we help our clients manage risk, ensure compliance with industry standards, enabling them to develop safe and reliable vehicles for drivers, passengers, and other road users. Additionally, we offer comprehensive functional safety devices that cover the entire development process, including design, development, testing, verification, and certification. Our experts work with clients to identify potential risks and hazards and develop strategies for managing them. And lastly, we also provide training and consulting services to help our clients understand and comply with industry standards and regulatory requirements. Our functional safety experts have extensive experience and can provide guidance and support throughout the entire development process. So I'd like to take you through each of our speakers and just some housekeeping rules. We will have a Q&A session at the end, so please answer write your questions in the chats provided, I think the Q&A section, and we will endeavor to answer your questions. So now I'd like to turn it over to our first speaker, Andreas. Thank you.
Thank you so much. Functional safety is our topic for today. And yes, maybe all of you have heard about different things regarding new mobility. So we have a lot of additional features and functions in vehicles. Everybody's seeing on the news, or I have practical work with it, I don't know. But from this point of view, of course, functional safety for the automotive world is one piece of the cake, and we have a huge field in functional safety experience at TUV. And the TUV standard itself, it's derived from a basic standard, which is used in several industrial areas. And we want here to see that functional safety is a topic in a huge or in a larger context. And when you see a lot of interfaces between functional safety, EMC behavior of a vehicle, environmental testing, electrical testing, and so on. So we have a lot of interfaces to cover. When we talk about functional safety, it's not on its own. You see it always in a larger context. Yeah? Okay, and regarding this context, I want to go to the next and we'll ask here, for example, Philip to go on, yeah? And my question is here that we have a lot of different standards available who shall help us, to win this challenge. So modern vehicles and electronic architectures, we need to consider that we have, the normal quality managed standards, but additionally, we need to cover a lot of combination of different standards. Here are only the most important ones. So when I would ask you, Philip, as a safety manager, what is the scope of the standards? What do you think? What is important? For example, for the ISO
Well,
26262.
Very good question, because naturally the functional safety 26262 is seeking malfunctions that address harm to any individual. So the nominal performance is not in scope, but when that nominal performance fails, then you shall identify those in safety requirements at the top level safety goals, derive them to safety requirements, and then make sure those safety mechanisms necessary are embedded in the design.
Yeah.
As you can see from this picture, that this is very complex, and we need to make sure that they operate safely in their functionality.
Yeah. To give a very short example, you see a lot on such kind of picture, but it only should help you to understand the complexity of such a system. And we have on the left-hand side, you see the normal structure for functional safety, high-speed can, low-speed can, all the different items like brake control or engine control or door locking systems, on the low-speed can. Everything is connected in the vehicle, and we have to fight and keep care that also security is done. This is the standard 21448, 21434. So the green one in this picture, and in this, of course, several teams working on this, but it's highly recommended and important that you consider all the steps together, that you have a good picture that this is working on not only separated working steps. So what would you propose regarding Sotif? What is enhanced on Sotif for the Sotif standard when we talk about this?
As you say, as this picture reflects, the nominal performance of the vehicle, so the braking, the steering, those have the nominal performance as they are open market typically developed. And Sotif then makes sure that the systems, braking, steering, acceleration work together as intended, so it operates in the field safely. So that's why on the right-hand side, you have this infotainment, which has the possibility for conflicting or integrating and violating the operation of the normal performance, whereas Sotif tries to, as an umbrella, make sure they all operate together. And so it's very clear how it shall operate in the field versus how does it operate with inside the vehicle.
Yeah. So for the combination, there's a good example to start work when we come back to this topic during this webinar is, of course, when you consider hazard and risk analysis, which is necessary for Sotif, which is necessary for functional safety. You combine it a little bit with the threat analysis, not in deep, but you need to know what impact in functional safety should be given. I give you an example. Everybody of you knows the Jeep problem where somebody hacked it, get into the vehicle, and the driver was filmed and he couldn't brake. So what happens that a reset occurs in the brake system every 100 milliseconds from outside, And from functional safety point of view, normally you control this and say, oh, this is an abnormal situation. I cannot restart a car 10 times in a second. So I skip this information and I stop. Yeah? So you want to implement additionally functional safety measures into several items. And what you said, Philip, from obviously from the outside, when the whole vehicle is working, you also make sure that some of this malfunctionality is covered additionally by Sotif. Yeah. Okay, to
I think
the
we'll cover that in the next slide.
yes. So I have to click on the next slide. Sorry. Okay. What is important, of course, for functional safety? We have an increasing topics, which is we have a very good add-on and a new standard which occurs last year. In the middle of last year, it was finalized, so-called Sotif. And because of this new technologies of autonomous vehicle functionalities or intermediate functionalities for automatic driving, we have new risk, new technology risk, and we need to keep care that this bugs which can occur or failures which can occur or dirty sensors or broken sensors covered by the whole system. Yeah? And we do not have unexpected behavior of the vehicle and also no harm to other traffic participants around the vehicle. Yeah? So for this special, how should a safety manager handle such kind of topics, Philip? Any idea? So,
Well, I think you'll see that as we go into the material further, there's a thing called a HARA. And that HARA allows you to analyze the functionality and see what impact it has on the expected requirements, the intended functions. And as you see this list of the technology risk, it's very well summarized, because does the system, the vehicle, the autonomous vehicle system have bugs in it? Does it have the hardware failures in the ECU or the sensors, the performance limitations, or say the common problems that you see on dirt on the sensors because they're obviously on the perimeter of the vehicle during operation? So all of these things are clear indications that need to be considered in a HARA. You do for functional safety, 26.26.2, and with Sotif you enhance with these new technical risks on top.
yeah, and a lot of classification have most of you have seen, for example, for driving automation levels, yeah, regarding the SAE J3016. We have a lot of different influence to the whole responsibilities, to the development teams, and to adjustment. So, Ruben, what do you think is here important? Can you explain the difference between level 2, 3, and 4 for all of them?
Yeah, for sure. Yeah, that's where it becomes interesting and tricky. So in a 2 setup, the driver is a consumer and has full responsibility of taking over the driving task anytime required. That means system failures, base vehicle failures must be detected, or complicated traffic situations must be detected by the driver, and the driver needs to take over and needs to be fully alert the whole time. And in contrast to that, the responsibility of the driver in L3 is limited during the time when the system is performing the driving task, until the system itself actively requests the driver to take over. Although it's a bit tricky in J3016 because the driver still needs in L3 to detect base vehicle faults, him or herself. And a concrete example given there is the broken suspension component. Then, of course, it's up to the developer how to handle such concrete hazards, right? They don't need to assign that hazard detection or fault detection in that case to the driver. But it should be considered that in different US states, different laws apply regarding the liability of the person in the driver's seat or the owner of the vehicle. So that needs to be considered on a case-by-case, state-by-state basis. And then L4 is when the vehicle then is really driverless throughout the whole journey, meaning that the vehicle could in principle be designed without a steering wheel and pedals. And it's also important to note that for legal reasons, an L4 system, including a safety driver inside the vehicle, should not be confused with an L3 and or L2 setup.
Okay, that's a very good difference between all these levels is necessary to keep care. Yeah, and it has a huge impact on your daily work, I'm sure. So what is the normal impact on these different levels? What do you think, Philip?
Yeah, so first of all, we at TÜV Süd differentiate between assessing prototype vehicles and vehicles that are intended for serial production. So often in case of prototype automated driving systems, the customers that come to us do not intend to comply with the before mentioned industry standards. So we apply our own safety assessment framework, which is like a TÜV Süd proprietary one, and it's loosely based on a certain set of regulatory and industry practices. And then for serious production of ADS, automated driving systems, the requirements actually need to come from the OEM or the AV manufacturer. So it's not usually the component or subsystem manufacturer that comes up with these requirements. That's because the OEM or integrator, they have the legal responsibility for the vehicle safety. And they also know which market is the target and what are the regulatory requirements for that market. So when those requirements are clear, then they can come to TÜV Süd and order certain assessment or certification services. And then about the different levels. So level 2 is not really something that is considered by the laws or regulations in the USA. L3 is something that is usually called in the laws an autonomous vehicle, and L4 is called a fully autonomous vehicle. And there are different laws applying to those two categories, and they are omitting the L2 category. And and common technical requirements in those laws are something that relate to the takeover mechanisms for a person that's in the vehicle. It's about minimum risk conditions and also obedience of traffic laws. And there are also implications for permits, exemptions, how to register the vehicle, what insurance do you need. And all that can differ from state to state in the US. And TÜV Süd can support customers with this complex landscape of 50 states. And and the same counts for the previously mentioned industry standards. TÜV Süd can support there. And we will look more into detail how these standards really apply in the US to these different cases that we will do later in this webinar. But it's important to understand that in the US, even though the standards might be voluntary, it is important that manufacturers comply with or are able to make a state-of-the-art claim regarding the engineering and their safety approaches because of liability issues that you might have otherwise.
Yeah.
And those standards important point. Assessment which we perform.
You mentioned a very important point, which is highly recommended to consider briefly is product liability. And so state-of-the-art is what the normal thing is known by the standards. Yeah. So when you develop regarding state-of-the-art, you are using actual standards like Sotif, like ISO 26262, or like the automotive cybersecurity standard. Yeah, always to avoid state-of-the-art known failures, and especially during development, avoidance of systematic failures. Yeah? And what is a systematic failure? Philip, can you give us an example, for example?
Well, naturally, you're going to want to have, as shown on this slide, if there's an item like a battery management system that's going to support or autonomous functionality that you have, you want to make sure that on the right-hand side, you see the functional safety that says the HARA how do I make sure it operates safely as designed, and you look at the malfunctions. Whereas the Sotif, what you see here, is enhancing to say, how well do I define the operation of the vehicle in the field? And so with EV cars, we have to consider making sure the system is well defined and the operation of the total vehicle operates in the field correctly. And that's where they complement each other together.
Yep. So we need to keep care of the requirements from the normal functional safety standard, but also performance requirements have a big impact on safety. And you mentioned one.
And during our time when we work with you, either in training or in assessing, we're helping you see and understand how your functionality, how is integrated into the system, and so it can deliver to your customer, or as Ruben said, to the regulatory body. So it's a matter of making sure this distributed development works with one common approach to operate safely.
Yeah. To add to this is what you also see on this slide is, okay, it's highly recommended to use organized activities. Yeah, maybe some of you have heard using safety planning or doing and planning all the safety activities. And here on the picture you see, okay, one document like the HARA give you an output, yeah, like a safety goal. And this output is necessary to derive more detailed requirements. So you have always a top-down, very easy traceability of requirements and avoid that you forget requirements. This is also important during this kind of development. For the Sotif and for functional safety and combining all these different standards, there are such more, especially when you work on the hardware point of view and you have to calculate running FMEA. You do a lot of things during the safety life cycle. Then you have to consider, let me say, 50 different standards or industrial sources. But now it's starting point that we really consider, okay, we need to derive the safety concept, what you derive from the safety goal, and with the help of deriving the ASIL level, ASIL level 1, A, B, C, and D are the different levels which you normally give you the outcome, how much measures you have to implement, how much work you have to spend, of course, on the verification steps, which kind of method you have to use, and so on. So during deriving our concept or our safety concept, we consider to get the first high-level requirements. And from these requirements, normally you perform safety measures. And these safety measures could be that somebody says, okay, for this activity, it's very good if you're starting with a review. Okay, that's one safety measure. Another safety measure is you finalize the phase. A very good safety measure is doing an assessment, which is supported by TUV also. And the outcome of the plan, do, and act circle, what you see here is always that you have a planned and organized way to consider that you don't forget safety activities, that you manage your safety activities, and that you collect during the life cycle, which can also occur 2 years, 3 years of development, your safety case is increasing. And the safety case itself, yes, you collect all this information, what you have seen at the beginning of this webinar too. All interface information are necessary in the safety case too. not only safety information. You need to consider what is about EMC test, what is about the high voltage test, and so on. So this results and also additional information are collected in the safety case. You also think always when you have a requirement on verification steps, and one of the verification steps is running an analysis. Another is doing a calculation, yeah, or running a test. So when we talk about analysis, Philip, what is the best way to start with this analysis?
Well, naturally, my favorite is FMEA, to know what the known failures are. And it helps you to select which are safety related and non-safety related. That helps you implement in your impact analysis. So you take these requirements from the HARA, you figure out which work products you need to cover into your safety plan, and then you can plan the work. So if you show on the next slide, you can see the importance of knowing what work needs to be done, and you then have the ability, as shown, where all those verification activities you need to cover. So FMEA helps you understand the feasibility of the requirements, planning the activities. The change in configuration management helps you make sure you have a structure of all those work products. And then the next aspects, there are several verification methodologies and reviews, tests, and obviously analysis. FME is just one of them. BFA, fault tree analysis, there's several in there. But you need to find an effective way that's safe for you to develop your product, and we're there to help you do that in your process of doing it.
So, what is your practical experience regarding assessments for during development? Any good recommendations from your side?
Well, like the Plan, Do, Check, Act model, what I think functional safety is all about is do the work, do your verification, and then complete the confirmation measure before moving on. That's not normal in the normal way of doing things. We have a tendency to jump in and want to innovate a great new design.
Yep.
Take advantage of that work, do the verification, and then do the confirmation before moving on. That's a very valuable step, and having that independent assessor helps you make sure you find those systematic failures and remove them from your design.
Yep. So when we come back to our entrance point, how can we describe how a functional safety manager can incorporate that Sotif and functional safety work products are sufficient at the end? So what is your proposal?
Well, naturally, a functional safety manager is a combination of a project manager, naturally a QM type of role, and naturally understanding the domain. That way, that role has the overview and has the ability to deal with all the different influences to the project. With the experience and also knowing when he or she is not understanding everything, knowing when to go outside and get that consultation necessary to be sufficiently safe, because you're trying to address all these unreasonable risks. So the combination, as the slide of the Plan, Do, Check, Act, is an iterative process. So you always want to go back and make sure you've covered everything and ask, like the three of us here, one is doing the work, one is doing the verification, and one is doing the assessment. and have those three independent roles always active.
That's right. And from the practical experience when I have done a lot of assessments in the US, for example, at different customers, OEM, Tier 2, Tier 1, and also software vendors or hardware vendors. One very good outcome for all of us was, okay, the companies have educated some staff who can maybe do this by the knowledge, but they really figure out after several different assessments, I don't want to stay in the shooting line of the management. I want to be, I need some help from an external role. And this external role, of course, is not mandatory in the standard or is not required by the standard. But from the practical point of view, all of the OEMs here in Germany, for example, who's starting a new project are doing this. Yeah? So what you mentioned, Philip, somebody's doing the work, please let's check the work and then run a phase assessment. Yeah? The phase assessment is not really addressed by any kind of the standards, but it's a practical way to avoid an increasing cost during development. I guess 99% of you know as early as you figure out a systematic failure, you can avoid cost at the end. Yeah? So you have an exponential increasing of cost if you couldn't detect a failure early enough. And if you develop a wrong safety concept and at the end it doesn't work, yeah. So therefore analysis is necessary.
So we'll see that on slide 14, but the next slide is talking about one of the things is our tools. So how would you describe the impact of tools on our project?
Yeah, we have, it is over different standards, but of course, regarding the ISO functional safety standard, ISO 26262, the same, you need to qualify your software tools. So when you're running or using analysis, or when you are running a test, or when you run a software test or a unit test, you need to qualify this tool or tool chain. So therefore, you consider these different work products, you classify it, and you check them. Yes, this tool impact, is the first thing what you consider. And when you have a tool error and tool detection, you can calculate your tool impact. Yeah? So the tool error means what happens, what can occur when the tool is doing a wrong thing, translation of a wrong sequence, for example, when you have a compiler, or wrong variables. And you consider additionally, how is it easy for me in the development process to detect such kind of error? Yeah? When your tool chain allow you to detect it, or you have an additional review which can easily figure out that you find this, then your tool impact is low and no qualification is necessary. If tool impact is high, so this is only difference is 1 and 2, you need to qualify your product, your tool, and qualification can mean, okay, confidence in increased confidence in use. So you need an argument, you need to write down why you are trust this compiler. Yeah? You are using this compiler for the last 3 projects, 4 years, and you have a complete bug list, is a very good argument to use it up to different ISO levels. You cannot use it in all ISO levels. For example, ACD, it's highly recommended to have a qualified tool. This is normally done by tool vendors or with a complicated process. Yeah? So from this point of the tool, what do you think, what impact have this tool chain on your project, Philip? What do you think?
Well, the big impact is those that are classified as 2 or 3 require, say, more preparation in the safety plan. So at the beginning of the project, you need to predict all the tools you're going to need, like for the hardware in the loop testing. You need to think about all of those tools you're going to do to verify your product meet the requirements. So if you could switch to the next slide, we could then talk about those tools that you're going to use. For example, do you have a laptop? Is it qualified? Does it have an impact? Is it qualified to check and detect the quality of your product to meet your requirements and your safety mechanisms? So you have to consider all of these things in the V model, the requirements, the specs, and all the way through to the right-hand side. And sometimes you're going to need help from external to make sure your safety plan addresses them correctly and you don't make a systematic error. So with that, you do the work, and then on the next slide, it then highlights the confirmation measure that are necessary to say, as you as an assessor, how would you assess if my safety plan was done correctly?
Yeah. So you need to run the correct confirmation measures regarding to your ISO level and to your role, of course. Yeah. And when you consider these confirmation activities, you can make sure that you have a correct output of hazard and risk assessment, for example, that everything is available and the correct output. Yeah.
Right.
Or your safety plan is complete, or the technical safety concept is tested, yeah, by analysis or by review. Yeah. And what is about your test strategy? Yeah? What you have seen on the slide before, using hardware in the loop test. Yeah? What is your test strategy, and when a test is finalized, and what are the criteria of this test regarding pass and fail? Yeah?
Yep. And in summary, the next slide shows exactly that point, right? As an assessor, how would you verify and confirm my safety plan meets the requirements?
Yeah. When I ran the role of an assessor, it was important to do it, of course, derived over several days, look in each phase, and it's important to see the whole safety case, yeah, and create together with my customer the assessment report. Yeah? So release for production of the item shall only be done after you have run the assessment, and when the assessment outcome is you have no big findings, you can go easily, or you have to wait and do the step. Okay, so we are very good prepared for the whole safety life cycle, and we want to run also a small conclusion, and I want to ask Ruben regarding this different impact in the US of different standards.
Yeah, so when we talk about standards, I think we first need to look at regulations. So sometimes the regulations tell us which standards to use. So it's a bit more complicated than that. So in the US, it's the regulatory landscape for L3 and L4 driving is less strict. So that's the topic that I'm gonna focus on now, L3, L4. Yeah, so, but as I mentioned earlier, we have the topic of this state-of-the-art argument in the context of liability. And so it definitely makes sense to look even at the, I would say, softer recommendations that are given out also on the federal level. We're going to look also into the state regulations just now a bit. So bear with me regarding that. So I'm showing here the outline of the NHTSA document called ADS 2.0, A Vision for Safety. This is also a document that relates to the VSSA, the Voluntary Safety Self-Assessment for Autonomous Vehicles. And it consists of 12 aspects of safety that should be taken into account by the AV manufacturer. So I'm not going to read through all of them for you. I've mentioned the document. You can look it up yourself, and you will also get the recording of this presentation later on. I just want to show how everything relates then to the industry standards later on. So what we can say from here now already, so I'm going to build up a larger picture, but what we can say from here already is that for the aspect that they call system safety, which is, I would say, more like the functional safety aspect that we already talked about in this webinar, there they really refer to 26262, and literally they say they encourage the use of the application of industry standards such as ISO 26262. So that is interesting, of course. That is not legally binding, but it is a certain hint already. And who knows, in the future this can become legally binding. In the EU already we have stronger indications, I would say, that this standard needs to be applied for these systems. Yeah, so I'm going to build up a larger picture, as I said. So from these 12 aspects, what we feel is missing there is the safety culture of the organization as such, and then also the aspect of AV testing operations. So many of our customers in the L4 field specifically are still doing test operations with in-vehicle fallback test drivers, IFTDs. So that's also an important aspect. And then I'm also showing on this slide already that there are traffic laws which relate to the OEDR task of the vehicle, which is the object and event detection and response. So that's like the main driving behavior and also performance of that. Yeah, that definitely relates to the traffic laws. Those are hard requirements. Often also it is explicitly said in laws that an autonomous vehicle must be compliant with all traffic laws. Sometimes there are exceptions for autonomous vehicles in certain traffic laws in certain states. So that's quite interesting source of requirements. Okay, and then we have the, for example, FMVSS, Federal Motor Vehicle Safety Standards, which relate to some of the aspects also mentioned for or inside the vision for safety. And we're going to build it up further to come to the industry standards and best practices. So those are in light green, and some of them are marked with a blue frame. When they're marked with a blue frame, it means that they're mentioned in another document, which is from the US DOT, and it's called AV Comprehensive Plan. It's a document that came out later than the Vision for Safety, and it does not really tell what to do with these standards, but it already mentions them in a long list. So this is also only a subset of standards that they mention. And then we see that the standards that we discussed today, 26262, is covering certain aspects of the Vision for Safety, and 21448 is covering certain other aspects. So when these aspects of safety are put out by NHTSA, then the question is always for the manufacturer, how do I cover them? So what you definitely can do is you can go for these standards mentioned here, and that is the state of the art, right? Yeah. So there are also some best practices mentioned from the AVSC. I will not talk through all of them, and yeah, I'm happy to accept any questions regarding that, and keep in mind, keep it on a higher level. We don't want to discuss all the standards which are on this slide here, but mostly the 2662 to 21448. Thanks a lot.
Thank you. Yeah, so some takeaways for today. Yeah? So for you, it's very important that functional safety and Sotif are becoming increasingly important, yeah, regarding new mobility. So you have to handle both. And while there's a stronger regulation in the EU, also for the US market, ISO 26262 and 21448 is a big topic, yeah, and has a big relevance. So it's also not mentioned as a technical standard on its own. It describes the whole has a whole impact on your development procedures. You imagine, and most of you know, in quality managed standards, and ISO is on the top, yeah, of a quality managed standard, so that you cover here best practice, and also that you can cover state of the art. Yeah? And TÜV Süd can you very good support you along all this functional safety and Sotif journey. So here is the most important impact on testing, recall testing and product certification on several kind of products or subsystems which are not possible during development. When we talk about this product certification, most of you have heard safety element out of context, for example, when you produce a sensor to measuring the voltage on battery systems, and the temperature, then this is maybe a safety element out of context. You can sell to all OEMs and tier ones and tier twos. Then this product needs so-called an inspection. That's the second topic here on what you can see. And an inspection keeps care that every year is this process and product and all these bugs which occurs, how you handle this, how you handle recalls and failures on the market are really done. Yeah. So for all others who do not need a certificate to sell their product, they need an assessment and audit and system. We call it system certification and can support you very well here for step by step what we mentioned over the whole webinar. Do it at the right time. You save a lot of money. You avoid trouble in your own company and especially on money when you run the system certification intermediate phase assessments and so on. So we support you also and give you a lot of information like this. Knowledge service is given, especially by also additional different freelancers or what else can directly support you when we do the assessment. So assessor and supportment cannot be the same, but different departments can do it. For example, Academy can support you, give you a knowledge service, and mobility department, which is represented by Ruben, can do the assessment for you, for example. Training, of course, is highly recommended also to save a lot of money, to avoid failures, to have the right knowledge at the beginning of your projects or during your projects. And you have also an evidence what you really take care of is an requirement of all the standards that you need to show an evidence of competence. So thank you for all of this, and we need to consider here, of course, that additional webinars will occur, especially on Sotif. There are so many topics, Ruben. I'm sure. So we have a lot of additional information for you on more details. Okay.
I see, Andreas, I see a question in the chat. Does ISO 26262 suggest anything about feasibility analysis of all the requirements? Oh, yes. Part 3 says do a HARA analysis on that item definition, and naturally it's supported by FMEA to describe those requirements. So you can do the assessment both at the top level to determine which ones are safety goals, because that harm could occur, but the FMEA takes the known failures and translates them into safety related and non-safety related.
Yeah.
So the feasibility of which concept to support that is also supported by that methodology.
Okay, there's another question about the difference between the terms assessment, audit, and certification. So I can quickly explain that one. Of course, it's a complicated topic. So a certification can include an assessment and an audit. It leads to a standardized label that, for example, TÜV Süd can give out. Then there are different types of certifications. There are certifications that are accredited, for example, by the DAX, DAKKS, the German accreditation bureau. And there are also certifications that we give out without that DAX accreditation. So that is roughly about certifications in general. Then, of course, there are many different certifications that we can give out for the different standards and so forth. So an audit usually refers to the process landscape of an organization. And it usually includes a part which is like some kind of live part, where there's a remote meeting or there's an on-site meeting and evidence is collected, questions are asked, documents are shown live. So that is that. It can also include, of course, the offline citing of documents, either for preparation or already for auditing. An assessment is largely paper-based, but it can also include, of course, testing of the vehicle, and it focuses on the product. So the organization has processes, for example, processes in compliance with 26262, and that can be audited. And then when you develop a product, you want also that product to be assessed or even certified. And for that, the TÜV Süd can look into the specific project or at the specific product to do that. So the basic requirement is the organization is compliant with the standard. That means that it's possible that the product comes out compliant, but it still needs to be assessed on the product level. I hope that was a comprehensive explanation. Otherwise, feel free to put more questions in the chat or in the Q&A.
While we're waiting for another chat, I like, Ruben, your point. The assessment is making a judgment of either an individual work product or the whole work product is meeting according to the standard. So you're right, and an audit is making sure that flow work is supportive. And I think that's an excellent point. And then the end, there are several, as you say, potential certifications that are available. But the slide that's showing is that's what TÜV Süd can help you in general. It's a matter of helping you learn the importance and how to be effective by understanding the standard correctly. That's where the training or the services, but this audit and system helps you along the way to make sure you develop according to the standard and catch it early rather than letting it get out late. Okay?
Okay.
Any other questions?
So what, regarding these services you mentioned, Ruben, what is the best practice? Should companies do it by themselves, or should they better use independent organization or independent departments? From the practice point of view, what is your recommendation?
Yeah, if you're a functional safety manager like I have been in the past, and my experience is it's good for you to work it and understand the verification internally. You ought to execute that confirmation yourself, but to be truly independent, this is where you need to have an independent assessment like TÜV Süd to make sure that confirmation measure is done according to the standard. So you want to catch it as early as possible so you don't develop further your products in the field or later. So you don't want any surprises. You want to be proactive and catch it as early as possible. So yes, it's a little bit extra cost, but it's a matter of making sure you're proactive. I see there's another question.
Yeah, we have another question. Maybe I start it and then we can discuss it if there are different opinions here in our team. So can you apply 26262 concepts to an already developed product? My answer would be no, because you need to have development processes. During this development process, you even need to take meeting notes and so forth, right? This is something that you cannot build afterwards. You have processes in place where people can speak up about the safety of the vehicle already during its development. That is something that you cannot like reinsert into a readily developed vehicle, which maybe has the flaws because nobody spoke up before, because there was no process to do it. That would be my short take. Certainly, we can discuss a lot more about that.
It's a very good.
Can I just add?
Good answer. Yeah, please.
Could I add another side? When you're innovating inside out, some of the experience has been you get a concept developed, and then you go back and apply functional safety, as you said, Ruben, and make sure it does take care of the nominal performance, and then you add the additional safety mechanisms on top. So when you're in an innovative, creative mode, you sometimes have to make sure your concept is working. But you're right, you have to go from start to finish to comply.
Right. And also what you mentioned, it sometimes definitely works to add a safety mechanism later on. I'm pretty sure there are examples when you have like a large outer loop. But when you look at, for example, you chose a hardware already, then the hardware does not have that fault detection that you need. You cannot inject it anymore, right? Because the processor is already laid out and printed and everything. So sometimes it might work, sometimes not. So I think that's a good discussion.
Yeah. It depends. I think the point is, it depends on each product. And that's what you have to add in your safety plan.
Yeah, but the kind of reverse engineering is, as you mentioned, Ruben, very difficult because you need always the different activities and evidence that you have done it at the correct time. So recommendation from us is, we have done this in practical use several times for customers, but then you starting with all the process steps, from the safety plan. Of course, you reuse your knowledge, but you consider the whole concept again and step by step get all these informations and results.
Yeah, we have one last question. I'm not sure who wants to take it. It's about the safety concept. Is it just performing CSRs, or is it about creating safety architecture?
When we talk about safety concepts regarding functional safety, we have minimum two. So it's called a functional safety concept, which is derived after the hazard and risk analysis. When you are sure what is your safety goal and what is the how you want to reach the safety goal. So maybe you have 5 or 6 high-level requirements which describe not the technology itself. It could be independent. Yeah, the technical safety concept itself is then derived from this functional safety concept, and you have a very clear picture of requirements and how you want to implement technical solutions like a special microcontroller, go down to hardware drivers and software, operating system you want to use, and so on. All this belongs to the technical safety concept. Yeah? And from the job of a functional safety team is, of course, to create different work products. The safety manager shall keep care that all these different activities are done by independent staff. Yeah, so you have a good opportunity to find failures during development and also in documentation or missing requirements. Yeah. So, thank you so much for this information. And up to now, I see we don't have too much minutes. We can talk several hours, no problem, and answer more questions later on. But now I want to switch over to Laura. Huh? Is it correct? Laura, are you there? Okay, then then I will say thank you for your attendance of this webinar, and it is very good that we have this communication, that you put in your questions, and hopefully you can take some of this information home to get a good idea what are your next steps in your daily work, and helps you also to avoid big trouble during development. So
Yeah.
thank you
So
for
Laura
your
had
attending.
technical problems. She wanted us to let you know that we're gonna email every participant about the recording. And so thanks a lot
Thank
for
you.
attending. Bye bye.